a larger length on the x-axis and a shorter length on the y. But you've got to be consistent, okay? All of my lengths on the x-axis now have to correspond to that, and all of my ones on the y-axis have to be small. You got to be the same on each axis, but you can have a different scale on the x and the y. Does that make sense?
Yeah.
Okay? So now from here, because you've only got these 2 points, I want you to label that you went over 1, up 1, which I did not do.
Well, why are you drawing it right now? Because he's done.
I'm done. I've got the x-intercept. There are no x-intercepts, and I've got every other bit of information. But I want you to label the points on either side of your vertex.
So it'd be 4, no.
So this was the point -6, 1.
So it'd be 5 over 1.
Now, from here, remember, Nimi, I went over 1 and up 1.
But how did you get 7?
So yeah, I said 5 over 1 and up.
How did I get which? Should be 1, 2, 3, 4, 5, 6.
Wait, is that when you use the A?
This is when you use the A to get these 2 points, yes.
Isn't it 5, 1?
Nope. If I go over 1 and up 1, then where am I?
10.
Now, over 1 from -6, 1.
-5, 2.
Yes.
What
I'm
is
at -5 on the x and 2 on the y. Because I went over 1 on the x, up 1 on the y. And now on this side of my
Wait,
parabola,
why 2?
because we went up 1, so that changed the y value of the
Oh,
coordinate.
but you were already up 1 already.
We're up 1, and then we went up another 1.
Ah.
We were at -6, 1. Oh, that's a good point. Nimi, when you go use A like slope and go over 1, up 1, you go from the vertex. You don't go from the axis.
But in that it's fine.
I'm glad it does. So then this side, I go to -7,
Over 2.
comma 2. Not over 2, but yes, right idea. And so if I label these 4 points, this is what I insist on seeing if you have one, if you pull a parabola out of a hat that has no intercepts. You know, okay?
You said it goes up from the vertex, right?
Yes.
Oh, okay, good. I mixed up the 2 words.
Okay.
Oh my.
So this would be, I mean, I'd want you guys to be neater about this. I don't have graph paper up here, and I kind of rush that. So this is the parabola you get. This is what I'd expect it to look like. If you're really good at the stuff we've been doing on the last couple tests, kind of a good news, bad news thing. Good news about this method is if you were terrible at the stuff we were doing on the last test, you can still follow this method and it will always work. If you're good at the stuff we've done at the last 2 tests, this could have been a faster problem. Okay? And I'll show you how real quick.
By
with some work.
completing the square.
By completing the square. If you get one that's like y equals x squared plus 12x plus 37.
Or even
Okay.
37 over.
Well, let's not do that. That's if you're solving. We still have y here. Remember, what you want to do is use completing the square to change this to vertex form.
So you get x squared plus. Oh, never mind.
So I'd say change it to y equals x squared plus 12x plus 36 because that's what I really want to be there.
Yeah, but when you do 37.
And then plus 1 because 36 plus 1 is the same as the 37 above it.
So would you have x plus 6 squared?
X plus 6 squared plus 1. Now, if you remember how vertex form worked from last December, if you're really good back then if you're in vertex form, you change the sign here,
Oh yeah, -6, 1.
and you leave the sign alone here, and boom, I have my vertex. If you also remember from last December, the vertex always, the axis of symmetry always goes through the x-coordinate of the vertex. So now I know my axis of symmetry is x equals -6. I find my y-intercept the same way, which is, it's going to be 0, 37. I put in a 0 for x, a 0 for y, and then I know a equals 1, so I simply go from my vertex over 1, up 1.
That's
Which-
much simpler.
Yeah, thank you. Which is easier, this or what we did over there?
Well, this one makes more sense
That's,
because that's what you've been teaching.
Vertex form?
Yeah. This is quicker if you remember what we did on the last 2 tests well, and if you remember what we did in December. If you got a really good memory for what we've done since December, and I give you this parabola, you could be done with all your computations in 5 minutes, then you just have to draw it pretty. Okay? And I'm going to put a couple of these in there. Do you guys know what the term Easter egg means in a video game?
You know?
It's not like a bonus for either really good or really lucky players. There's a really dumb one in the game Deus Ex, which was one of my favorite games years ago, where if you happen to round a corner that you have no reason to round and it's really hard to see, there's a basketball in a basketball court, and your player can drop his gun, pick up the basketball, and shoot some hoops. Does nothing for the game. It doesn't move the game along at all. It's just a fun little bonus for people to happen to notice.
They give you Easter eggs on the SAT.
Yeah, well, this is like an Easter egg. If you notice that this is almost in, if you remember how to use completing the square to get from here to vertex form, I have no problem with you doing it this way. And you will be done faster than other people. But if you don't remember that or think you're going to screw this up, then for God's sake, do the method I taught yesterday, which will always work.
Which is a safer way.
That is a safer way. The big point, but you can use your own judgment. You get to pick how much work you do if you get one like this. Now, if you pull one out of the hat, I'm just going to do another random example here. If you happen to be one of the unlucky souls who pulls one out of the hat, and it looks like y equals negative 5.2 x squared minus 1.3x minus 52.
And I'm burning, so I never know.
Right, then, if you get something that looks like this, for God's sake, just do the method I taught yesterday, okay? Don't even try anything fancy with this. But if you get one that looks like it's almost in vertex form, go for it, if you remember it. Does that make sense? If you're lucky, and you were paying attention the last couple months, you will have less work than the people sitting next to you. If you are unlucky, or you haven't been paying attention for the last few weeks, then you got more work than the people sitting next to you. In one sense, this is fair because I'm leaving it to luck. I'm not picking who gets what assignment for this.
Why
Okay.
luck?
Well,
What if you did it by cat?
this is a little bit more of an accurate preparation for life than I actually mean it to be. Okay. Your 3 parabolas for the weekend to practice before you get your official one on Monday. And I will check all 6 parabolas on Monday.
Today.
Yes, the ones from yesterday and from today. So if you didn't get them finished, you got a little extra time. Your parabolas are
Anyone?
1, y equals x squared
Let me memorize all this stuff.
plus 14x plus 49. I don't memorize anything. I know the patterns well enough that I'm making these
that
up.
one works. It's a perfect square.
So how many x-intercepts does it have?
Oh.
1.
1. Boom. There you go. If you get the patterns, this stuff's easier. 2. Y equals 2x squared plus 10x
25.
plus 51.
Nope. That one.
If you're good with... here's a quandary one, okay? I'll be honest with you. This one, because I'm good with fractions,
You can run on my 2.
I could... Not the 51 makes that harder. I could do this one faster by this method because I'm really good. But I will tell you right now, that will lead you into fractions. And if you're terrible with fractions,
Oh, no.
you may choose to do this one a harder way. You know what I mean?
So
like
want
if
it to
you're-
be 50? No. 25.
I'm going to leave that for you to think. And if you don't think you can reason it through and be careful with your fractions, do it the longer way.
I have a question.
Yeah, you
One
want
sec. You got one more of these. Equals 3x squared
plus 9.
minus
No.
12x plus 35.
I think the first one's the best.
I think this one's terrible. Actually, I don't think... Well, there might be a shortcut to this one.
Don't want to know.
This one I would look for the shortcut for maybe a minute, and then I would do it the other way with the quadratic formula and everything. If you want to do all 3 of these with the quadratic formula and all that. But I tried to pick 3 with no x-intercepts. So remember, you're going to have to use A
Oh.
for the 2 points on every single one of these. If you've got 1 or 0 x-intercepts, you need to use A. I need 4 points.
Can you look at this, please?
Okay, Becca, we're